Welcome to GetXAML. In this video, we will understand the concept and the mathematical model for multiple linear regression. So previously, you have seen simple linear regression. Simply, we modeled it as y equal to the intercept plus the slope into x. Now, what is the concept of multiple linear regression? Multiple means yes, how will you get your linear regression model? Because now this y is dependent on all these features. So we will write the same straight line equation y equal to beta naught plus beta 1 x1 plus the slope for this feature, that input, so on up to, say, there are p features or p inputs. So what exactly this means? If I take the linear regression line, let us say this is my y, this is my x. There are different points, different data, x1, x2, up to xp, like that. So say these are the data points. Okay. So this will create one regression line. Suppose say there is another data x2 feature. Okay. So this will create another regression like this. So there are different features, different inputs. So previously in simple linear regression, it is dependent on only one variable x. Here there are multiple variables like this. So this is called multiple linear regression. Now this is your straight line equation. This is our predictor value. How will you get it? Okay, this is sum of all the linear regression for each of the variables x1, x2 up to xp. Now, how to find this? So to make it simple, the simplification part, so we convert this equation form into the matrix form. If you convert into matrix form, it will be easy to solve this and get our model. So how will you convert? So let us say y, this is a column vector. Means what? Y contains y1, y2 up to say yn. Okay. N is the sample size. N is the sample size. Then how to model my x? See, this x matrix, I can model it as, see, there is, I can write it as beta naught into 1, beta 1 x1 and so on. So the first one is all ones, right? Coefficient. So up to say n, total n ones. Next, so this one, so this is x1, okay, and then it is variable 1. Let us represent as x11, then x12, so on up to x1p, the last one. So you will write second x2 1, x2 2, so on up to x2p. So you continue like this for all the variables in your system. So I'll get it as this is xn1, xn2, so on up to xnp. So this is how I form the matrix. That means you take for each, because this x1 means what here? The x1 is also of this form, right? This is a column vector. x1 is a column vector, which will have something like this. Okay. So I have converted it into matrix form like this. Now, how will you convert this beta, that is slope? Slope again, it is also a column vector. Column vector, what is? So beta naught It's a intercept. It is common for all. See, the intercept for the lines remains same, okay, where it cuts y. Then beta 1, beta 2, so on up to beta p, not n. Why? Because I have beta naught to beta p. N is the size of the input. Now, if you observe here, this is y is a n cross 1 matrix. This is, there are total n rows into, so p plus this one. So there are total p columns plus this one column. So p plus 1. This is the size of this matrix. Here it is again a column vector, a column matrix. Here the size is p into, or p plus 1 into 1 column. So how can I write this now in the matrix form? Y is equal to x matrix into this beta column plus some error. So there is some error already there. That is what I'm mentioning. So this is called random error. Already I've seen this. This is a random error which is inherent in the system. Now if you see what is the order to multiply this, the order should match, right? So the column number of columns in x should be equal to number of rows in this beta vector. Otherwise I cannot multiply. So y is of size n cross n. This x is n cross p plus 1 into p plus 1 into n. So the size will become, after multiplication, this will be n cross 1, and this is a error vector. So this is represented again like single vector. Okay. So epsilon 1 to like n. Okay. So this is n into 1. So I can add this because all of same size. So this is how I represent my multiple linear regression in the matrix form. This is the final equation. Now we'll see how will you estimate the beta. This one I have to estimate, no, slope. See, here it is not a single variable. It is a column vector. Okay. So that is nothing but what beta is equal to beta naught, beta 1, so on up to beta p. This is what I have to estimate using my regression equation. So again we'll use OLS method, that is ordinary least squares, by using the concept of residual sum of squares. Okay. So this is given as summation of I equal to 1 to n, that is sample size ei square, right? This is for single variable. When you have a single variable, you solve it like this. Now since this is nothing but a column vector, right? How will you write it for multiple variables? Let us take this e as a column vector. This e, the residual error, is nothing but e1, e2 up to e p. Okay. So sorry, en. So how will you write this e? E is equal to the true value minus the predicted value. So here it's a vector, right? Both are vector. This is the final result I got. This is the true value. So this is nothing but, we already know, y minus this y is nothing but what? Beta x. Okay. So this is what I have found out there. So I'm just substituting that value here. Y minus beta x e. Now in the matrix form, how will I find my RSS? RSS is equal to, can write as e square, that is multiplying these two matrix. How will I multiply this? So e and then e. So this is e1, e2 is a row vector. Then e1, e2, so on up to en. This is nothing but what? E transpose into e. So my RSS, I can write it as E transpose into E. What is E? So I'll write RSS is equal to y minus beta x transpose of this into y minus beta x. This is my RSS. See, all are here matrices. Okay, this is not single variables. All are column vectors or matrices. Now, how will I minimize this to obtain beta? So, differentiate and equate it to 0 to get minimize it. So, with respect to beta, this is a matrix equal to 0. If you do it, we'll get estimate for beta is equal to x transpose into x inverse into x transpose into y. So, this is the column vector. This is the column vector. So that means what? Beta is something looks like this when you solve it. So beta naught, beta 1, and then so on up to beta p. Okay. So now finally what will be your equation? Your estimate is equal to beta naught plus beta 1 estimate into x1 plus beta 2 estimate into x2 plus so on up to beta p estimate into xp. So this is my final multiple linear regression model. Okay. Now let us take a simple example and try to understand this. So they are given x1, x2, and then y. Is given as 1, 1, 4, 2, 0, 5, 3, 1, 8. So you fit the multiple regression model for this. So what is that you have to do? You have to first, this is what I am trying to find. Beta naught, beta 1, x1 plus beta 2, x2. And then estimate these values. Then you will get this. How will you solve this? So you already know the solution. First you convert this into matrix form. So what is my y vector? Y is 4, 5, 8. So there are 3 samples, n is equal to 3. Then my x is equal to, the first column will be all ones. Then x1, x2, 1, 2, 3, 1, 0, 1. Then my beta vector, I can form it as beta naught, and then beta 1, beta 2. So what we got the solution? We got it as estimate for beta vector as x transpose into x inverse into x transpose into y. So that is nothing but what? Matrix multiplication, take inverse, again transpose of x, multiply with this resultant and then multiply with y. So although it's simple equation, but multiplication will take much time. So what we can do is, in such case, you can go for 2 approaches. I will give you. Okay, how to solve this? So you first convert this into system of linear equations. System of linear equations. Okay, how will you write? So what was the matrix? So we'll write x beta is equal to y. Let me write it like this. What is my x? X is 1, 1, 1, 1, 2, 0, 1, 3, 1. Then beta vector is beta naught, beta 1, beta 2. This is equal to y vector is 4, 5, 8. Now, you will check for two things here in the exam. If they ask this, first you convert this to system of linear equations. That is, here only you can quickly check. So it is beta naught plus beta 1 plus beta 2 is equal to 4. This is beta naught plus 2 beta 1 plus 0 is equal to 5. Then I have beta naught plus 3 beta 1 plus beta 2 is equal to 8. Now in this you observe, is it easily reducible, or else if they are given you options, then you can put the values and try to eliminate the other options to find this. Okay, but if it is a little bit complex, okay, one way is what, if it is simple, you can just cancel the terms here and find out beta 1, beta 2 and beta naught, then fine, you go for directly subtraction and then some adjustments here, or check by option. This is simple case. Else, if you are not able to find, so you can go for row echelon form. So try to reduce this matrix. So convert this into augmented matrix. So this way also you can solve. Okay, or you go for matrix reduction using row. To get the row echelon form, you first get the augmented matrix. Okay, the matrices and linear algebra concepts I have explained how to form the row echelon form. Okay, so let us write the augmented matrix. This is my augmented matrix. So now, so what the row echelon form says, if this is my pivot element, the first one, then the elements below it should be zeros. If I take it as pivot element, the element below this should be 0. So now you try to convert this first to 0. How will I get it? R3 is, I am making the row reduction, R3 minus R1. So this is 1, 1, 1, 4, 1, 2, 0, 5. So 1 minus 1 is 0. 3 minus 2 is 1. 1 minus 0 is 1. 8 minus 5 is 3. Okay. Next, now you try to make this element 0. So R2 is R2 minus R1. This one will remain same. So 1 minus 1 is 0. 2 minus 1 is 1. 0 minus 1 is minus 1. 5 minus 4 is 1. Then this will remain same. Okay. So now this is acting as a pivot element. Now try to make this as a pivot element. So you have to make this element 0. So how will I make that? R3 is R3 minus R2. So this becomes 1, 1, 1, 4, 1, 0, 1, minus 1. If you see here, 0 minus 0 is 0. This becomes 0. 1 minus 1. So 1 of minus 1 is 2. Then 3 minus 2 is 2. So now it's in the standard row echelon form. So now you can directly get my values. This is nothing but what? Beta 2 is equal to 2 beta 2 is equal to 2. This implies beta 2 is equal to 1. Then from the second row, this is beta 1 minus beta 2 is equal to 1. So this will become beta 1 is equal to 2. Then the first equation, beta naught plus beta 1 plus beta 2 is equal to 4. So beta naught equal to 4 minus 3 is 1. So I got the beta 1, beta 2 and then beta value, beta naught. So now you fit the regression line. So predictor is equal to beta naught 1 plus beta 1 is 1 in 2 into x1 plus 1 into 2. This is my multiple linear regression model for this data. This is how you have to solve. In the next video, you will see some of the standard errors and how to calculate them, and how it is like R-square error and all those things, how it is applied to multiple linear regression. Thank you for watching. Please like, subscribe and share. We'll continue.